Because the lowest.
There you go. Jess, I heard you. Something about this guy. Now this is interesting, everyone, because that is the absolute min right there. Do you agree?
Mm-hmm.
But the slope of the tangent line drawn to this curve here is not 0. Do you all agree the slope of a tangent line to this curve would be undefined?
Yep.
So we're going to have to put a side note. I'll get a sheet to you, but we'll go, all right, if I got to find max and mins, it's where the derivative, I set it equal to what? 0, and then we'll put a little hush in the parentheses and go, or where it does not exist. Because there will be some what? There won't be many, but there'll be just some rare cases where you could have a function and what? The derivative does not exist here. Remember this, everyone? No JVCs?
Mm-hmm.
So let me just go through that again. If when it comes to finding these max and mins, we're like, this is what we'll do. We'll get the first derivative of that function. We'll set it equal to what? 0, and we'll figure out where it equals 0, or we'll say, oh, where it does not exist. Just in case we get something like what? This. And you go, well, what are some examples? And when in mathematics, maybe we got a function that has a what? A fraction, and what makes these fractions undefined? When the denominator is what?
0.
0. So we'll consider that as well. Not only will we find out where the first derivative equals 0, we'll say, figure out when that denominator, just check it out. You never know. It might be an asymptote there, right? Might be an asymptote, not have anything there, but we'll just keep that in mind because, Jessica, you just came up with a great example. Say, hey, be careful. Sometimes max and mins can occur where the derivative is non-existent. It's a corner. It's a corner, so we'll look at that as well. Cool. Man, you all are great. Some have some. Anybody have any other functions with like an absolute max or min?
Okay, what?
That was good. Did you hear this? How about the sine curve? We have to go plural though. Why? We're actually say plural absolute maxes and mins. They're all the same. What's it doing? How high does it get every time?
-1 plus
Oh my
1.
gosh. There's a bunch of that. It's like a tie, huh? The absolute max is what number? 1. So that's how we talk too. You put the answer as the y value. What's the absolute maximum of y equal to sine of x? 1. What's the absolute minimum?
-1.
Negative 1, right? Where does it occur? And you go, a lot of places. Do you agree? At what x value does it occur? A lot of places. You can put that +2 in pi if you want to.
Mm-hmm.
But we'll just say a lot of places. So that was a good one. That one has absolute maxes and mins, right? Now,
What about the
can they ask the question, this is what we're going to do in 4.1. Can they ask a question about absolutes if the graph doesn't have absolutes? They can, but when they do this, be aware of something. They're going to cut it off in a certain domain. Okay? So we're going to do one like that. All right? I'm going to give you a function where, Josephine, you know it just goes off forever, like this way or that way, like an x cubed. But they're going to say, find the absolute maximum and the absolute minimum points on the interval from -2 to 4. Okay? So if you wanted to even check this stuff on your calculator for checking purposes, take your window and set the x-min and x-max from what? -2 to 4. Does that make sense?
So like a piecewise function?
Exactly. But even probably easier art. So if we had a graph, let's say the graph went like what? Like this, right?
Mm-hmm.
And they go, everyone find the absolute max and min, but they said only on the interval from 1 to 4. You might find yourself cutting off what? You might go left with something like that. Right? Does this make sense? You'll cut off the entire graph if they said only from 1 to 4, and you're only looking from here to here. Now a lot of you are laughing and go, well, this is going to be easy if I look at my calculator, because where's the absolute max occurring? Right there. Do you all agree? Where's the absolute min?
No.
Right over here.
Right here, yeah.
So,
Wait, so does that work for graphs that go just like apart, just like a linear graph?
yeah.
And there's like a relative or absolute max and like a absolute min.
Mhm.
Okay.
So, and what we'll do is we'll just cut it off from some region. But they'll state where to cut it off from. They'll say on this interval. Does that make sense? So, there must be something else to this technique. So, let's talk about this. We're trying to find these, what do we call them? Absolute maxes and what? Mins?
Mm-hmm.
But they're going to cut it off on some certain domain. Okay. Is there another word for absolute maxes and min? Yeah, we can say extrema, if you like that word. If you've heard this before, extrema. It's just a word to mean what? Maxes and your what? Mins, if you like to put it in your notes. So we're going to find absolute extrema. I could have said relative extrema, but 4.1, we're gonna start with absolute, right? If you're curious if there's only one absolute max, you can make that singular. If you wanna know how that word is spelled as singular, it's this. That's the singular form of that word. Extremo. But plural's what?
Extrema.
Extrema. So hey, find the absolute extrema for this function on the interval from -2 to 3. So, can we talk about what we're going to do? We're going to find what derivative? First derivative. What are we going to set the function, set it equal to, the first derivative? 0. Why? Because what happens here? Slope is 0. But look at the image I just did. What was here before? It was a graph that went like this, went like this, and then went like this, went like this, like this. But we cut it off on a certain interval. Only going from like here to here. So for our, directions, our step-by-step process, we're like, okay, we're going to get the first derivative. We'll set it equal to 0. We'll solve for x. But there's something else we're going to check. What can we call these points? The end what?
Endpoint.
Endpoints. We're also going to check the endpoints. Because one of those might be the what? The absolute max or min. Someone got that?
Mm-hmm.
So this is, we only do that if they cut it off on a certain domain. Someone got that? All right, let's do one. So I'm going to page, 281. Everyone, can we do number 49? I was looking for a fun one. What's the page again?
289.
281, I think.
281.
Here it is. Find the absolute. Okay. Maximum. As I'm writing this, isn't this something you could check with your calculators? Yeah, all right, good. Minimum. Values of f here's the function, everyone. 2x cubed minus 3x squared minus 12x plus 1. Now, and if I just stopped right there, you'd be laughing at my question. You'd be like, there's no answer to this, I'm sorry. Because we know about x cubed graphs, don't we?
Mm-hmm.
Don't they just, right? I mean, you can't do this. So right after this, guess what they do? They give you some interval. So they go on this interval. On the interval, 0 to -2 to 3. Interval -2, comma 3. Now these are x values. So we're going from what? -2 to 3. But everyone, I know you might be like, let me go look at the graph. I'm going to go blind on this. I'm going to do this because I can't even see the graph because I don't need it. Because I know the process. I'm going to check the endpoints. What are the two endpoints? I'll check those. You go, what do you mean I'll check them? I will take those numbers and I will plug them into this equation and see what I get. And I'll record them and I'll write them off to the side. And then I'm going to compare them to something else. What am I going to compare them to? I'm going to get the first derivative. And what am I going to set it equal to? 0. I'm going to solve for x. Right?
If it's the same.
Yeah. Is there a name for that, everyone? When you take the first derivative and you set it equal to 0, or where it does not exist, all right? And you solve for x, is there a name for that point? Yes. In calculus, we call them critical points. So if you want to put that down. Thankfully, they put a name to that. So you don't have to go, the points where you set the first derivative equal to 0 and you solve for x, or where it does not exist, all right? Now, did you want me to write that down on the board? What definition of a critical point?
Yeah, please.
Yeah, okay. By the way, I'm going to give you a sheet to everyone that what? Has all this stuff on there. I had to handwrite it because it was hard to type, so I handwritten. I put it all on one sheet where I did everything from like 4.1 to 4.3, a big summary. But on there you'll see this definition. What's the definition of a critical point? A critical point is a point such that f prime of x is equal to what number?
0.
And then I'm going to put in parentheses, or what? Yeah, just put a D in it. For cases like yours, Jess. It is a value that doesn't exist. Do you want another example of a critical point? This is not the square root of x. This is called the cube root of x. I'm just going to draw this graph. You would find a critical point right here. Right there. You go, oh, that's not even a max or min. True. So now we're determined, we've realized something, everyone. Not every critical point has to be a max or min. All right? Because at this point, right here, the slope is not 0, but the slope what? Does not exist. Does that make sense?
Mm-hmm.
So you might have, there might be some cases of critical points where you're, oh, that's not a max or a min. It's just a place where the,
Tangent.
yeah, vertical tangent. Slope does not exist there. But we can still call this graph has a critical point at x equal to 0. There's not many of these. That's why we just lightly put it in the parentheses, right? See, this is a smooth polynomial. We don't have to worry about this part, right? But this is what we're doing for this problem. We're going to check our critical points versus our what? Endpoints. Does that sound good? And when we're going to find our critical points and our endpoints, and we're going to take each one of these x values and we're going to plug it into what? That. And who's going to win the game? The absolute max is going to be the absolute highest y value. The absolute min is going to be the absolute what? Lowest. And then we're all done. I say we check it on the calculator, right? Although I know some people, Claire, they look at the calculator first, which is fine. I know. It's up to you. I would definitely check this during an exam if you can get the graph going, right? It's going to show you the image. Is there a max and min button? Yeah, but let's treat this as, you and I, we're going blind here. All right, first of all, what's my endpoints?
2 and 3.
Negative 2 and a 1.
3.
All right, let's just get a little table ready. We don't have to do it right now, but I don't want to forget about this. Trust me, it happens. In a testing situation, people will forget to check the what? The endpoint. So let's just get it up there, we'll be prepared. All right, let's go over here. These are the endpoints, right, everyone? Here's our critical points. What are our points? Critical points are points such that what? They're x values. So Kelly, they are x values, but what's going on? The
If-
slope of x will be 0, right?
0,
Slope of
doesn't
10.
exist.
So everyone, can you help me take that derivative?
Yep.
All right, here we go.
6x squared minus
6x squared, keep going, Art.
minus 6x
Minus 6x.
minus 12.
And what's the derivative of this plus 1?
0.
0. Don't you love ones like this? We don't need chain rule. We don't need quotient. Don't you love these? Give us more of those. I know. That was nice. All right, so we get all this. But I said all this equal to what? So here come your algebra skills, and I heard Kelly already. Everyone, you crank into this algebra mode, and I love it. She was all ready to do it. You looked at this and you go, all right, I got to solve that. And I don't feel like doing quadratic formula. Kayla, I remember you and I were doing that quadratic formula the other day. I was like, can we avoid it? Let's factor. You said, what would you divide on both sides? So I'm going to do that. I set the first derivative equal to 0, and we're just trying to find x. I can see there's going to be 2 of them. So she divides a 6 on both sides. So you divide a 6, you divide a 6. What's 12 divide 6? And then look, I divided it on both sides. Well, this is the good news. What happens when you divide a 6 from a 0? 0. Yeah, so that's just 0. Did anyone see that? You go, wait, don't I have to factor it out and leave it there? We're solving this equation. Divide a 6 on both sides. And now we all know how to factor this. 2 numbers, multiply to negative 2, and add up to negative 1. What are they?
X minus 1 and 2. X equals to number minus 1 and 2.
Rock and roll, everyone. So here they are. X equal to 2, critical point. That's a critical point. There's another critical point where? Cool, Josephine.
Did you use the intercept on the calculator to find out the correct answer, or do you have to do it that way?
To find the intercept. I'm with you. Oh, hold up. That's not a bad idea. Josephine, are you saying, let me know, you could go to the y equal button and not type this in, but type this in. I wonder if you follow her. She's taking out her calculator. She's going to y equals. She's typing this equation in. And then she's looking at the what? The x-intercepts. You would find these.
Or,
That's good thinking.
or you type that in and then.
I don't ever want to say that's not the way to go around it. That's actually good thinking. I love how you think like that.
And you put the other y equals.
Because what you're doing is
We did a
you're
problem
graphing a derivative.
before.
And I like that, Josephine. But you could do that. You would find these values that way. Right? And you just go to 0, right? Or intercept. If you do intercept, make sure you make another equation equal to 0. Okay? What she's using, everyone, you might go, well, why didn't she just factor? Maybe, and I'm not putting Josephine on the spot, but maybe a student's like, no, I'm not big on factoring. You know, I've never had factoring down, but I have other skills. I got another skill set. I have another place set where I can take this tool. I know other ways to what? Find these values. Okay? So Josephine, that's absolutely fine. Cool? Absolutely fine. She goes, I'll just grab that thing. All right, cool. Now, everyone, I made this little table. Let's make a little table for this. What do we got here? X and Y, and what were the two X values?
2.
All right. Now, be prepared. Sometimes this has happened when you practice some of the textbook problems, everyone. This is going to happen. You're going to get one of these numbers. That's a critical point. That isn't in this what? Domain? So what should you do with that? Who can answer that? It's going to happen. There'll be at least one. I remember I signed at least one problem. I want to make sure so students can know what to do with it. What if you get a value that's, you get a critical point over here, but it's not in here? You got to toss it. Why? Because the question's only asking what? Only on that what? Interval. Does that make sense? So keep your eyes out for that, Claire. If you get if you got a number over here was like -8, you go, well, I can't use it because it's got to be between a -2 and 3. So we're checking these, that number, that number, that number, that number. Whoever's the highest wins as the max, and whoever's the lowest is the what? The min. If there's a tie, we say there's 2 maxes. If there's a tie between the min, there's 2 mins, right? Sound good? Sometimes there's ties. We know that. You get even functions. True? But where am I plugging these?